Hello everyone, in this video, I will explain you these two questions that are asked in the Mumbai University question paper in December 2023 and December 2022. The same question is asked to solve the RSA algorithm, but the first question is asked in December 2023, explain public key cryptography and RSA algorithm, and the given modulus n is equal to value 91, value of public key is equal to 5, and you have to find the value of PQ, value of N, and the value of D, that is your value of private key, using RSA algorithm. And later on, you have to perform the encryption, and the value of plain text is given, that is N is equal to 25. In the second example, in the second question, what is asked in the December 2022? The same question is asked, but they are directly asking to solve the example, that is in an RSA system. Given value n is equal to 91, value of E, that is public key, is equal to 5, and you have to calculate the value of 5 of n, P, Q, value of your private key, that is P, and what will be the ciphertext after encrypting the value, that is message is equal to 25. As well as you have to perform the decryption in this example. So the same type of question is asked in the two exams, 2023 and 2022, in December question paper. So now, first of all, you can check what do you mean by public key cryptography. So the public key cryptography, that is also called as asymmetric key cryptography. So there are two keys will be used for encryption as well as decryption process. So here the public key will be used for encryption process and the private key will be used for decryption process. So there are two users, that is sender and receiver. So receiver's public key will be used for encryption and receiver's private key will be used for decryption process. So this question is asked for 10 marks in the exam, and the first one is they are asking for explaining the public key cryptography. So the 2 marks will be given for this public key cryptography with diagram and explanation. 2 marks will be given for the RSA algorithm. In that you have to write down the RSA algorithm. And the rest of the 6 marks will be given for example. But in case of a second example, you can check. There is no theory question is asked. Directly they are asking for the example, but they are asking for the decryption process. But in the first example, they are asking for only encryption process. Okay. So in the first one, that is in the public key cryptography, you have to write down the public key, that is the receiver's public key, will be used for encryption and the receiver's private key will be used for decryption. So two keys will be used for encryption and decryption process, and this kind of cryptography will be called as public key cryptography and asymmetric key cryptography. Now the second step is you have to find out encryption as well as decryption process, but before that you have to write down the RSA algorithm. So RSA algorithm starts from the step number 1, that is step 1 is P and Q, these are the two large prime number. So first of all, we have to choose two large prime number. Then we have to calculate n is equal to P into Q. Now the third step is we have to calculate the value of phi of n is nothing but P minus 1 into Q minus 1. The fourth step is we have to select the value of our public key. And your public key value is between value of 1 less than E less than phi of n, and it should not be factor of n. It should not be factor of phi of n. Okay. Now the next step is we have to find the value of our private key. So value of private key is equal to D into E mod of phi of n is equal to 1. So this is the formula for calculating the value of your private key. Okay, as well as you have to check GCD of E phi of n equal to 1. Now for process of encryption and decryption, we have the formulas like encryption is equal to, that is ciphertext is equal to plain text raised to E mod of n. So n is nothing but value of P into Q. And the decryption process, which you will get a plain text message, that is P is equal to C raised to D mod of n. So D is your private key and E is your public key. So in that way you can write down your RSA algorithm. Now we will solve our example. So in the given example, the values are n is equal to 91 and value of our public key is equal to 5. So first of all, we are writing here value of n is equal to 91. Now we have to find the values of our P and Q. So we have to check that what is the factor of that 91. So we can write it as n is equal to 91 is equal to, we can take it as 7 into 13. So if you observe this 7 and 13, these are the two prime numbers. So we can consider here P is equal to 7 and Q is equal to 13. These are the two large prime numbers. These are the two small numbers, but as per this algorithm, we can consider it as our two prime numbers. Now the second one is, we have to take the value of our phi of n. So how we are calculating the value of our phi of n? So phi of n is nothing but our Euler's torsion function, and we can use the formula for phi of p is equal to p minus 1. As per this formula, we can put the value into phi of n is equal to, we are taking here p minus 1 into q minus 1, because here we are finding the value of our phi of p into phi of q, and these two are the prime number. So if the number is prime, then we can calculate the Euler's torsion function is equal to value of our p minus 1 and q minus 1. So here we can write 7 minus 1 and 13 minus 1 is equal to 6 into 12. And we got the value, that is 72. Now the third step is, we have to calculate the value of our private key, because value of E is already given. So value of our public key is equal to 5. So we have to check that our E should not be the factor of phi of n. So 5 should not be the factor of our phi of n, that is 72. So this rule is applicable here. Now the next one is, we can also check that GCD of E phi of n equal to 1. So GCD of 5 and 72 is equal to 1. So this rule is also applicable here. So now we will go for calculating the value of our private key. So private key is equal to D, that is not given in the example. So we have to find here the value of our D. We have already calculated the value of P, value of Q, value of phi of n. Now we are calculating the value of D, as per this formula, like D into E mod of phi of n equal to 1. So value of D into E, that is 5 mod of 72 equal to 1. So the formula for D is equal to 1 plus K into phi of n divided by E. But this formula should not work here. We are using extended Euclidean algorithm method to calculating our value of our private key, that is D. So first of all, you have to take here quotient, then value of A, value of B, then remainder, then T1, then T2, and the value of your T. Okay, now you have to put the value of your A, B, T1 and T2 first. So value of A is nothing but your value of phi of n, and value of B is equal to the value of your E, that is public key, because in this example the value of public key is given, that is 5, and your value of phi of n is 72, and here you are writing 5. So first of all you have to find out 72 divided by 5. So you will get the quotient, that is 14, and remainder you will get 2. And here you can write the value of T1 and T2 is initially 0 and 1. So you have to find the value of T is equal to T1 minus T2 into quotient. So according to the formula, value of T is equal to 0 minus 1 into quotient, that is 14. And you will get the value, that is minus 14. So I am writing this value here, minus 14. Now you have to shift this value as it is as 5, then 2, then you are shifting here 1 and minus 14. Then again you have to calculate 5 divided by 2 is equal to 2, quotient is 2 and remainder is 1. Now you have to calculate the value of your T is equal to T1 minus T2 into quotient. So our T1 is 1, our T2 is minus 14 and our quotient is 2. So for after getting these values, you will get T is equal to 29. So I am putting the value 29 here in T block. Then again I am putting here 2 here and 1 here. We are shifted these values. Then we will get here minus 14 and 29. Again after calculating 2 divided by 1, you will get the quotient 2 and remainder is 0. Then T is equal to again T1 minus T2, like minus 14 minus 29 into quotient, that is 2. And you will get the value like minus 14 minus 29 into 2 is equal to, you will get value minus 72. Now again you have to shift the value 1 here, then 0, then 29 and minus 72. And here you got value 0, then you are stop here, and after that you have to find your value of your D. So how you are calculating the value of your D? There are some rules are given. If the value of T1 is negative, then you have to add T2 plus T1. That is the value of your D, that is private key. But else, if your T1 is positive, then you are taking private key is equal to T1. So here the value of T2 is, T1 is not negative, it is positive. Your value of T2 is negative, but your value of T1 is positive. So that I am writing D is equal to T1 is equal to 29. That is my value of private key. So now we got the value of our private key, that is D. Now we have to perform the encryption as well as decryption, because in one of the question paper the encryption is asked, and in the second question paper encryption and decryption, both the process has been asked for the exam. So now first of all I will solve the encryption first, then we will go for decryption. So for encryption, the formula is ciphertext is equal to P raised to E mod of N. So I am putting the value here, that is C is equal to 25 raised to 5 mod of 91, because value of our public key is equal to 5 and value of our plain text, that is E1, is 25. So now we have to follow that rule, that is 25 raised to 1 mod of 91 is equal to 25 mod of 91, and you will get the value, that is 25. Now you are calculating 25 raised to 2 mod of 91. So here you can find 25 raised to 1 into 25 raised to 1 mod of 91. So 25 into 25, you will get the value 625 mod of 91. So now how you can calculate the value by using the calculator? You can check here how you can calculate the value into calculator. I will show you how this can be calculated with the help of 991 MS series as well as 991 ES series. So 625 mod of 91, you will get the answer by using calculator, that is 79, or also you can write 79 minus 91 is equal to minus 12. So you can write both the answers here. Now you have to find 25 raised to 4 mod of 91 is equal to 25 raised to 2 into 25 raised to 2 mod of 91. So you will get the answer like 79 into 79 mod of 91, and you will get the answer, that is 53, or you can write it as minus 38. So how this minus 38 comes? That is 53 minus 91. You will get the answer minus 38. Now you have to find the value of your 25 raised to 5 mod of 91. So you can write it as 25 raised to 4 into 25 raised to 1 mod of 91. So 25 raised to 4, you can write it as 53, and 25 raised to 1, you can write it as 25 mod of 91. And after calculation, you will get the value, that is 51. That is the value of your ciphertext. that is C. Now you have to find out value of your plain text. So here you have performed the process of encryption that is asked in the exam. You have to encrypt the value of m is equal to 25. So after encryption, you will get the value that is ciphertext is equal to 51. And based on that value, you have to again perform the decryption process and you have to find the value of your plain text. So in the decryption process, what is the formula? Plain text is equal to C raised to D mod of n. So C raised to D is nothing but 51 raised to 29. So D is 29 and mod of 91. So again we start the process like 51 raised to 1 mod of 91 is nothing but 51. Then 51 raised to 2 mod of 91 is equal to 51 raised to 1 into 51 raised to 1 mod of 91. And we got the value that is 51 into 51 mod of 91. We will get the answer 53 or minus 30. You can calculate it by using calculator. Now 51 raised to 4 mod of 91. You will get the value like 51 raised to 2, 51 raised to 2 mod of 91. And what is the value after calculating 51 raised to 2? That is 53 into 53. So you can calculate it as mod of 91. So now I am putting these values into my formula and I will get the value that is 79 by using calculator or minus 12. Now I have to find the value of 51 raised to 8 mod of 91 is equal to 51 raised to 4 into 51 raised to 4 mod of 91. So 51 raised to 4 is nothing but minus 12 into minus 12 mod of 91. And I will get the value that is 53 or minus 38. Now I will calculate 51 raised to 60 mod of 91 is equal to 51 raised to 8 into 51 raised to 8 mod of 91. So 51 raised to 8, I can put here minus 38 mod of 91. And after that, you will get the value is equal to 79 or minus 12. Now we will not calculate 51 raised to 32 mod of 91 because we want the answer for 51 raised to 29 mod of 91. That is 51 raised to 16, 51 raised to 8, 51 raised to 4, 51 raised to 1 mod of 91. So you can check the values here 51 raised to 16, 51 raised to 8, 51 raised to 4 and 51 raised to 1. So after putting the values here, you will get your answer that is minus 12 into minus 38, 79, 51 mod of 91. And you will get the answer like 1837224 mod of 91. And your value will be 25. So this is the value of your plain text. So in this way, you have calculated your plain text message and you have performed the decryption process. So in the given example, the value of n is given, value of E is given, and value of m is given. Based on that, we have calculated the value of P, value of Q, phi of n, our value of private key, and we have performed the process of encryption as well as decryption.